My dear darlings, welcome to a new episode of Build Your Own Tile System with ProBuilder and Unity. On the previous episode, we created a set of 4 tiles for our two-sided corner walls. On this episode, we'll do something similar for the straight walls, but we'll also learn how to drill holes to create doors and windows. There's a lot to cover, and there's no time to explain again what I've already did. So, please take a few minutes to watch the previous 2 episodes if you haven't yet. Let's get right into it. Please, drag the wall tile to the hierarchy window. Select Object Mode, go to the ProBuilder window, and click on ProBuilder Eyes. Orbit around to find a point of view where you can see the top face. Select Face Mode, click on the top face, and then on Delete Faces. Orbit around to find the bottom face. Click on it, and then on Delete Faces. Next, we need to rename the tile according to the rules we defined on the previous episode. Please rename it as Wall S2LR. And save the tile. As you may remember from the previous episode, this gizmo here is telling us that the left side of our tile is facing the camera right now. Click on the left face. Then click on Delete Faces. Rename the tile as Wall S2ZR. And save it. Orbit around to see the right side. Delete the right face. Rename the tile as Wall S2ZZ. And save it. Remove the tile from the scene. Go to the project window, and move the mesh assets to their own folder. Drag the Wall S2LR tile to the hierarchy window, and ProBuilderize it. Delete the right face. Rename the tile as Wall S2LZ, and save it. Remove the tile from the scene. Go to the project window and move the mesh to its own folder. We could say our wall tile set is complete at this point. However, most buildings have windows and doors, and none of our current tiles have any. So, we need to add more tiles to our set. Please bring the original wall tile onto the scene. We'll need to do some math on this one. Nothing complicated. Yet, is best if we reset the transform to simplify the calculations. Go to the ProBuilder window, and select Object Mode. ProBuilderize the tile, and find a perspective that allows you to have a better idea of the tile in relation to its pivot point. Let's start with something simple like a door. We have a wall that's 3 meters wide. Floor tiles are 0.2 meters thick. So, the wall's bottom is 0.2 meters above the pivot point and the wall's height is 2.8 meters. We're going to drill a hole to fit a 1 meter wide by 2 meters high door. Please click on the plus sign next to New Shape. Type 1 for the x-axis, 2 for the y-axis, and 3 for the z-axis. Build the shape, close the window, and reset the transform. With this, both pivot points are aligned at the world's origin. But the tile's pivot point is located at the center of the wall, while the new shape's pivot point is located to the left, so all the volume is on the right side. Because of that, if we want the door to be centered, we need to move the new shape 0.5 meters to the left. Also, the wall's bottom is 0.2 meters above the pivot point, so we need to move the new shape 0.2 meters up, too. Please do the proper adjustments on the transform. Go to the menu and click on Tools. Navigate to ProBuilder, Experimental, and select Boolean CSG Tool. Drag the wall to the left panel of the Boolean Tool window. Drag the cube to the right panel of the Boolean Tool window. Click on the Operation drop-down list. Select Subtraction. Click on Apply, and close the window. The Boolean tool takes 2 objects as input, performs the requested operation, and then creates a third object, as you can see here. The subtraction operation cuts the shape in the right panel inside the shape on the left panel. As you can imagine, the resulting shape depends on where you place the input shapes. To have a better idea of the result, we need to hide the objects we used as input. Please note that when the mouse hovers over the left side of the object's name, in the hierarchy window, an eye icon appears. If you click on that icon, the object disappears from the scene. Please do the same with the wall. If you remember from the previous 2 episodes, It should be obvious that the triangle count is not optimal. We can get rid of at least 4 triangles. 8 if the hidden faces are subdivided in the same way as the visible faces are. Let's optimize this mesh. Select vertex mode. On the left side, click on the bottom of the door, then on the middle vertex while holding Ctrl. Click on the plus sign next to collapse vertices. Make sure collapse to first is enabled. Click on collapse vertices and close the options window. The extra triangle was removed. To adjust the remaining triangles, we need to repeat the process. The bottom vertex is already selected, so just click on the middle vertex while holding Ctrl. And click on collapse vertices. Apply the same procedure to the right side. We also have to do the same on the interior faces. Sometimes it's tricky to click on the right vertices. Orbit or pan the camera if needed. Currently, the Boolean tool is in experimental phase. As you can see, at this moment the algorithm generates a lot of unnecessary triangles. Hopefully, when released, we won't have to do all this extra work. But that is something yet to be seen, so, for now, you need to use it carefully. To optimize triangles on the top face by collapsing vertices would be a very complicated procedure because most vertices are shared with other faces. We need a different approach. Please select face mode and select all the triangles on the top face. Then click on delete faces. Shift to edge mode, click on one edge, then on the opposite edge while holding Ctrl. And click on bridge edges. We just need to optimize the back face with the same procedure we used for the front face. Rename the tile as door. And save it. Remove from the scene the 3 game objects we created. Go to the project window and move the mesh to its own folder. To create the optimized tiles, please follow the same procedure we used at the beginning of this episode. If you need to watch the steps once more, please just rewind this video to 0 minutes 31 seconds. I'm going to skip that part to keep this video within a reasonable duration. Next, we'll create a window. But this time we won't use the Boolean tool. Please, once again, drag the wall tile into the hierarchy. Please, don't worry if you don't see it right away on the scene. It is there, but out of focus. Just reset the transform and it will appear. ProBuilderize the tile and find a more comfortable perspective. To keep things simple, we're going to make our window 2 meters wide and 1.5 meters high. If we set the snap increment to 0.5, it will be very easy to align the edges. Select edge mode and then select the top and the bottom edges. Click on the plus sign next to subdivide edges. Set subdivisions to 2. Click on subdivide edges and close the window. Select vertex mode. As you can see, the top and bottom edges are now divided into 3 sections. We're going to connect the vertices in the middle to create 2 new edges. Select the top and bottom vertices for the first new edge, and then click on Connect Vertices. Repeat the same procedure for the other edge. Select edge mode. Drag the left edge to the left until it snaps. Also drag the right edge to the right until it snaps. Click on the left edge while holding Ctrl. With both edges selected, click on Subdivide Edges. Select Vertex Mode. We need to add 2 more edges. Select the left and right vertices for the first new edge and connect these vertices. Then repeat this procedure for the second edge. Shift to Edge Mode. Select the window's top edge and drag it up until it snaps. Select the bottom edge and drag it down until it snaps. We need to divide the interior face in exactly the same way. As you may remember from previous episodes, the wall thickness is 0.2 meters. So, to ensure a proper snapping, we need to adjust the snap increment to 0.1. We cannot set it to 0.2 because we're working inside a cube of 3 meters per side with its pivot point located at the bottom center. In other words, 3 divided by 2 yields 1.5. Which, on a 0.2 meters grid, always leaves us either 0.1 meters short or 0.1 meters past the walls. Select Face Mode. Click on the Windows face and extrude it by dragging it along the Z-axis while holding Shift until it snaps with the exterior face. Then click on Delete Faces. Orbit around to see the exterior face. Click on the Windows face and click on Delete Faces. The extrusion process generated 4 extra vertices which we don't need. To eliminate them, please select all the 4 vertices along the Windows edge and click on Weld Vertices. And with that, we have our window. But before we consider it done, let's take a look at how optimal it is. Please click on Triangulate. As you can see, this method also leads us to a suboptimal mesh. And probably any other method to drill holes you can think of will leave you with an unoptimized mesh. But I trust you can apply what you learn here to optimize any mesh, so I'm leaving you that as homework. At the end you should have something like this. Once you have it, please also save it and create the 4 optimized tiles. In further episodes, we'll use everything we're creating on this series. That's all for this episode. If you enjoyed this video, please like and share. Remember, you can support the development of more videos like this one by simply subscribing to this channel, and when you do, please don't forget to activate the notification bell. That way, I can notify you whenever a new episode becomes available. Thanks for watching. I'm April McQuinn. Cheers, my darlings.